Okay, we're doing binomial expansions, which you've done before at AS. Difference now is that we're using this formula, and that's because the power we're going to be using is going to be negative or fractional. Notice that this has to start with 1. It's got to be 1 plus something to the power n. Okay, and in fact the first example is about as easy as it gets, because I've got 1 and I've just got a plain x here. So all I'm going to do is apply this formula. Okay, so I've got to go up to x cubed. This formula takes me as far as x squared, after which I've got to spot the pattern for myself. But we always start with 1. So 1 plus x to the power of minus 2. Starting term is easy, it's 1. The next term is n times x. My n is minus 2 because n is the power that we've got on the bracket. Okay, so I've got a power of minus 2. So 1 plus minus 2 times x. The next term is n times n minus 1 as the top of a fraction plus. So I'm going to have something times something on the top of the fraction. Well, the first term is n, that's my minus 2, that's still the power, and I've got to take away 1. Remember, when we take away 1 from minus 2, it gets to a bigger minus, so it's minus 3. On the bottom, this is not 1.2. This is how it's printed in the formula book. A bit confusing. This is 1 times 2. Okay, that's always 1 and it's always 2. It doesn't change according to n. And then we've got an x squared. Now, actually, it's quite nice to have this in a bracket, because when it's not an x, we will need those brackets. So I'm going to put them in now. Okay. And then the third term that it doesn't show me, well, it's obviously going to end in x cubed. Actually, this is the fourth term, actually, but it's the x cubed term. It's the term with the power of 3. And I'm going to have in front of that, that's going to be an x, and I'm going to have in front of that a fraction that begins the same way. It's going to be minus 2 times minus 3, because it's still going to have these same factors, n and n minus 1. But the next factor is going to be, doesn't actually tell you here, but it's n times n minus 1 times n minus 2. So that's going to be, take away another one, minus 4, and on the bottom it's 1 times 2 times 3. So they give you this bit, which may look a little bit scary. This is supposed to help you with all the other terms apart from the x and x squared terms. Okay, this is saying 1 times 2 times however many things up to the power of x you're using. And this is n times n minus 1 going down, and so this would be the rth one in that series, in that sequence. This may not be terribly helpful, but you do need to know how to extend the pattern after x squared. I should put plus dot 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 here. The thing about the binomial expansion when we've got negative and fractional n is that it ends plus dot dot dot. This is actually a series which may or may not converge. Okay, in order for it to converge, we need the modulus of x to be less than 1. This should remind you a little bit about GPs converging when the common ratio is between 1 and minus 1. It's a similar sort of idea. Okay, anyhow, all we've done here is we've lobbed the value minus 2 into the formula for n, and all we have to do now is simplify. So it equals 1, and then minus 2 times x is minus 2x. Okay, now in this particular case, yeah, I've just got an x squared from this bit, so I can simplify this fraction. A 2 cancels with a 2 here. Minus 2 times minus 3 divided by plus 2 is actually, so the minus times minus is a plus, so this is actually going to be plus 3x squared, and this is minus 2 times minus 3 times minus 4, which is minus 12, divided by plus 6 is minus, sorry, 24 on the top, isn't it? Minus 24 divided by plus 6 is minus 4x cubed plus dot dot dot. And I should state the range of validity. Okay, they often ask about this specifically, but this is valid when modulus of x is less than 1. So that's a simple example.